Ladies and gentlemen, please welcome Dork Shahagian.
Hi, and welcome back. It's been an amazing day. I'd like to introduce, my great pleasure to introduce Professor Andrea Dutton, just recently moved to University of Wisconsin. Andrea studies sea level and its relation to ice sheets during past warm intervals. We seem to be entering a warm interval now. If you ask any geologist in the world, they'll recite to you chapter and verse, the old uniformitarian maxim, the present is the key to the past. Maybe that's not so true anymore because of human activities. We've been perturbing things in ways that never happened before. But maybe the past may be the key to the future. Andrea will be speaking along those lines. Her work has been highlighted in the New York Times, the Washington Post, CNN, NPR, the US Senate. She's a fellow of the Geological Society of America, a Fulbright scholar, and very recently a MacArthur Fellow. So sea level. Sea level is really the integration, the result of interactions between the atmosphere, hydrosphere, cryosphere, lithosphere, biosphere, and society. I don't know, we call it a technosphere maybe. As such, it neatly encapsulates the essence of Earth covering and even links to Earth interior, beyond Earth, and nexus neighborhoods. So we end today's really awesome sequence of sessions with a few words from Andrea Dutton that might serve to link it all together. So with no further ado, Andrea Dutton.
Thank you. Thanks for being here. I know it's been a very busy day and there's a lot going on here. So as you know, the theme today on this stage has been Earth's covering, which covers a lot of AGU. And as Dork just mentioned, sea level is kind of an integrator of a lot of those things between what is happening in the atmosphere and the cryosphere and the hydrosphere and the biosphere and the Earth's surface. All affects what's happening in the oceans and in sea level. And so in that way, it's kind of a nice way to bring things together. And there's a lot of change, as we know, going on in our world right now. A lot of that's instigated by us. And certainly a lot of that change manifests through climate change itself. And when we think about climate change, we're spending a lot of time at these meetings communicating to each other with graphs and that type of thing. But graphs are not always so convincing to the general public. And so I put up these global warming stripes that I'm sure many of you have seen before, which is a much more effective way kind of viewing this temperature change that we've seen over the last century or so. It really speaks to people more when you see that transition from the blues all the way into the reds. And that's really going to be the focus of my talk today, is this pairing of not just the science that we're doing and the importance of it in this rapidly changing world and how that can help us to predict the future, but that it's no longer okay for us to just sit in our offices and do this work without communicating that to the public, because this problem has become so urgent that we've reached a point, it's not just upon also the people who are studying directly sea level change or climate change, but we've reached a moment that I think is all hands on deck, right? It's for all of sciences to have a voice, to not just explain what is happening, but also to be part of the solutions, because we're not going to get there unless we all participate in that process. And so I've chosen to kind of focus my talk on the science and the communication, in part because as we think and reflect upon the past century of where we've come and all the wonderful things we've done, and we look into the future, I think this is a really important future for the AGU and all of the disciplines involved in that as well. So when I asked them, what should I talk about today? Should I talk about the last 100 years or like the next 100 years? Or do you want to hear about my research? And they said, Well, yes, right? All of that. So what I'm going to do is really focus on some examples, really stories, anecdotes of strategies that I use to communicate sea level science to the public, and some of that relates directly to my own research that I'm doing. And I'm going to tell that story to you in 3 parts, talking about the deep past of sea level change, recent past of sea level change, and future projections as well. And along the way, I'm going to provide some of my opinions about how I see both sea level science and communication about that science evolving as we move into the next century. So to introduce myself a little bit further to you, most of the work that I do, I'm a field geologist. I go out in the field and I reconstruct past changes in sea level. And primarily I do that by studying fossil coral reefs that you can see here in this picture. And I drill rocks, which is a lot of fun, and I bring those rocks back to the lab, and I'm using those corals as an indicator of the past position of sea level through time. But along with that, an increasingly important part of my job has been to communicate the results of my research. And I started that in part just, when I had a big paper come out and I talked to the media. But it was immediately apparent to me that the implications of my research were really profound in terms of what we expect in the future. And that it was really important that I translate that message and help people to connect the dots, because it was clear to me that that message wasn't really getting across. But this is not something that I was really trained to do as a scientist necessarily, speaking to the public or speaking to the media. In fact, I told a story earlier today when I had to talk to the first journalist. I called up my sister because she had gotten media training as a doctor. And she told me, well, write down 3 things that you want to say, and no matter what they ask you, say your 3 things, right? And get that message across. And I still do that sometimes now to help me through that, especially in the early days. But I think as we move into the next century, we need to think more about training the next generation, not just in science and how to do the science, but also to communicate that science. And I've done that in a lot of different and varied ways. You can see some of the pictures here. I've been in different various NOVA documentaries. I've given a TED Talk. I've done all these different things. But if I can be critical of myself and my own approach, I've had some impact there. But I think there's a lot more that I could be doing, because most of these things are people who are self-selecting to come and hear me, to walk through that door for the talk that I'm giving, or when they flip through the TV to watch that documentary on climate change and not just go to the next thing. And I need to be doing a better job in connecting to the audiences that are not getting that message and are not part of this conversation, because they're not choosing to engage necessarily, not knowing that actually this is affecting them also. So as we move forward, I think one of the most rapid ways we can help to make that transition is actually to think of more diverse ways of communicating, and that includes including more diverse voices in the science and the communication part of it, to have more creative approaches in that. So I think that this is about science, it's about communication, and it's about diversity and inclusion within our discipline. And if you look at the sessions going on at AGU, if you want to know where we're headed, there are a lot of sessions on all of those things, right? But I'm going to tell you a couple stories while we're still on this slide talking about communication, because you may say, well, that's great for you. You can go give a TED Talk or do these things and talk to 300 people at a time, but that's not really my thing. But that's okay. It doesn't have to be your thing. There are different ways that you can engage. And to be honest, it wasn't really my thing in the beginning in the beginning. So I'll tell you that before I went to graduate school, I was a teacher at a private school in New York City. And I hadn't given a lot of oral presentations as a student. I was never really asked to do that. Again, I wasn't really trained to communicate in that way. And the very first day I had to teach, I got in front of those 6th graders, and I tell you, I felt the weight of their entire education upon me that day. I was so nervous about shaping these kids and molding them for the future. And I stood there, and the entire 40 minutes, the right side of my nose twitched like this, nervously, and it would not stop. I was terrified. Public speaking was not my thing. I was also terribly shy as a child. I remember standing at the grocery checkout and the lady saying hello to me, and my mom was standing next to me, and I wouldn't reply because I was told not to talk to strangers. And I was painfully shy, and I would not engage. Yet here I am, giving these talks and going out and doing these things, in part because I feel compelled to do so, right? And I think it's a burden upon me because I have this knowledge and because I spent all that time teaching in the schools. I got over my nose twitch. It only lasted one period, thank God, and then I was over it. But I managed to work through that because I think the payoff is definitely worth it. So if there's one thing that I want you to leave here today with is a sense of thinking of a new way in which you can engage in this conversation, to communicate to people, and maybe not the same people who you always talk to. Maybe it's the taxi driver I struck up a conversation with last night about the flooding last week. And a lot of that communication is actually about listening, I find, and not just talking, not telling people what's happening or what they should think or what's going to happen in the future, but asking them what they think and how did that affect you. And that is a really important part that communication is a two-way street, in my own experience at least. So as we think about this issue of sea level, it is really integrating the impacts that we are feeling throughout the Earth system. As the cryosphere is melting, as the atmosphere is warming, and it heats up our oceans and that water expands, the ice sheets melt, that induces changes in the solid Earth, right? And all of these things are coupled together. I also think that sea level is an integrator of human experience, if you will. A lot of people have a lot of attachments to the coastline, whether it's they vacation there, or their family has a holiday house, or they live on the coastline. There are other people who may not. Maybe people who live in this country, in the interior of the US, don't feel a connection to the coast, and they say, well, why is sea level rise going to affect me? So one of the messages that I often give about sea level rise is that it's not just about inundation, right? I have some friends who live in South Florida, and they said to me once, well, our house is at 12 feet, so we don't need to worry, right? If sea level comes up 3 feet, then we're totally fine. But it turns out there are a whole bunch of other things that are going to impact them. Even if their house doesn't get inundated, they might not be able to drive to work, right? Their access to fresh water might be impacted. If that water floods into toxic waste sites, and there are a lot of them, you can look these things up online, as that seawater comes in, how does that mobilize those things? How does it affect the sewage system as that water floods in? It becomes a profound issue of human health in these communities. When you get intense rainfall events now, that picture on the bottom right corner was just when it rained really hard in Miami Beach. And as sea level rises, there's no place for that stormwater to go and to run off to. And so as you get these intense rainfall events, you can all get this increased flooding that goes along with that. There's a loss of coastal resources, and there's a profound social inequity too when we think about the adaptations to sea level rise. There are some communities in South Florida that are throwing huge amounts of money into raising roads, installing pumps to pump out the water when you get these rainfall events. But those are only communities that can afford them. And if you were to build a seawall somewhere, maybe not there because seawalls don't work well when you have porous bedrock, but in other places where you build seawalls, you might be protecting one area, but that water has to go somewhere. So you're actually making it worse flooding in the places that can't afford them. And that's something that we need to think about as we move forward in making these adaptations. But there are economic impacts as well. And those have an enormous ripple effect, and they will ripple far into the interior of the country when the coastal housing bubble bursts, which it will at some point. And just look at the housing market in 2008 and think about when people start pulling out, and particularly the insurance companies start pulling out of those coastal markets, that will affect the whole country. And in fact, there will be global repercussions to that as well. I've been living in the state of Florida for the past 9 years, which is heavily reliant on the tourism and the real estate in these coastal areas, right? So the state economy will be affected as well, and that will have effects farther inland too. So oftentimes when people think about sea level rise, it's really only in this kind of myopic way of thinking about, well, what will get flooded? They're the ones who need to worry. They can just move maybe or something and not. But in fact, there's this whole domino effect that gets set off, which is something that we know as earth scientists about all of these things being connected together. Yet when we communicate about sea level rise, if you go do searches online, these are the type of images that you most often come up with. So when people are talking about sea level rise, or journalists are writing about them, you see these images of ice sheets or polar bears, and people look at this and they don't feel connected to this at all. Well, this is happening far away from me. It's some ice sheet that is far away, so why would it bother me here? And why do I need to worry about the polar bears, right? They're far away. And one of the key messages here is that the reason that this issue of sea level rise is so important is not just because the sea level is rising or the ice is melting. It's because of the ways it impacts us as humans. So we really need to put humans into this picture when we talk about it, but we also need to remember to be humans ourselves and not just talk about the science, but talk about how it might affect us personally, to connect with those people. So when you look at these images, they have a much more striking effect than the images of the ice sheet and the polar bears. So this comes out of an initiative at Florida Atlantic University where they took photographs of people, and if you can't see the captions at the bottom, so I'll read the one on the right that says, when Lauren reaches her life expectancy in the year 2078, sea level in Miami Beach, Florida will be 36 inches higher than today, and that's where it will come up to on her. And thinking about how are people going, we know this is coming, we know that sea level is rising. Yes, there's uncertainty in the projections, but we know it's going up and we know it's accelerating. So we need to prepare for this. And when you see it like this, you imagine how are we going to exist in this space, right? Rather than thinking about these distant impacts on the ice sheets and the polar bears. This one is one of my favorites. It's a sculpture in Berlin that's supposed to depict a lot of politicians debating global warming as sea level is rising up around their ears, right? And you may chuckle as you look at this and think about this, but somewhat ironically, only a few weeks ago in Venice, Italy, this regional council was flooded for the first time in history, and the politicians had just rejected a measure on climate change right before this happened. And I didn't make that up, right? Irony is thick, and when you look at that sculpture, like, oh, well, that would never happen, right? They would never wait that long before they did something. Yet here we are. I mean, okay, they didn't wait till it came up their ears. There are no people in these pictures because they ran out of the rooms, but they were sitting here moments before this flooded and actually happened, which means clearly there's still a lot of work for us to do. We seem to be trying to send this message, but maybe it's not getting through on the other side. If they're still sitting there debating and rejecting measures to address climate change as their council is getting flooded. I spoke to this taxi driver last night about the flooding that was here this weekend, right? Right before I got on the plane to come out to San Francisco, there was a big rainstorm. And here as well, as you get these heavy rains, more intense rains, the warmer atmosphere and sea level is rising, there's less place for that to run off. Here in San Francisco, apparently the stormwater system is not separate from the sewage system, right? So when this happens, it's not a happy thing. And we're clearly not prepared for it, and it's already happening today. Okay, so let's move to think about some of the science that I said I would walk through, thinking about what we've learned from the deep past and how that is important, what we've learned from the recent past, and then thinking about some future projections from sea level rise. So this is a figure that obviously motivates a lot of research about sea level rise. It shows the satellite altimetry record of sea level rise since about 1993 when they first put up these satellite records. Even over this short time period of a few decades, we can now detect a signal of acceleration in the sea level rise signal. The average over this time period is about 3 millimeters a year. Right, so when I give public talks on this, I say 3 millimeters, right? That's the thickness of about 2 pennies stacked together. And I swear I can hear the people snickering at the back of the audience thinking, oh, my beach house is good, right? You know, 3 millimeters a year. Like, what is that? Why are we worried about this? And then we put it into geologic context and show how that compares to what's happened in the past and how that's already changing our coastlines today and how they're out of equilibrium with that. But the real problem is, even from today, that 3 millimeters a year, when you look at the projections, all of the projections show accelerations. Because we expect, as we move forward, an increasing contribution from the ice sheets in Greenland and Antarctica. And some of that evidence is already starting to play out. The most recent report from the IPCC on the cryosphere was detecting some accelerations in the melting of those ice sheets that's leading to this acceleration in sea level. The problem is we have never been around to instrument that retreat from Greenland and Antarctica under climate conditions like this before. But fortunately, the Earth has been around for a while. It has experienced warmer conditions. So one of the things that I do as a geologist is I look at these past warm periods to try to understand how sensitive are these ice sheets to warming, How much will they retreat, and how fast will that happen? Right, so that's what I do. I travel around the world. I go to these fossil coral reefs to try to reconstruct past sea level through time to get a handle on the sensitivity of these polar ice sheets during the past warm periods. And a lot of the work I do has been in conjunction with this group called PalSea. It's an international, interdisciplinary group of people that brings in people working on ice sheets and modelers, people like me reconstructing sea level, so we can put this whole picture together. So a few years ago, we collectively as a community wrote this review paper to try to summarize what it was we understood from these past warm periods. How sensitive are these polar ice sheets? And in this cartoon, you can see portrayed the present on the far left, where sea level is 0 by definition. We've already warmed up the Earth's atmosphere by actually more than 1 degree Celsius, but I've rounded to the nearest whole number here, since the pre-industrial. During the last interglacial, only 125,000 years ago, the global average temperature was about the same. Yet, sea level, we think, was much higher, maybe on the order of 6 to 9 meters higher. And in fact, all these previous past warm periods we looked at, we expect sea levels were at least 6 meters or higher, with warming of somewhere between 1 and 3 degrees Celsius. So that immediately tells us that with what sound like very small changes in temperature, those ice sheets are actually very sensitive to those changes. Moreover, that if this is right, we've already warmed 1 degree, it implies that those ice sheets are out of equilibrium with our present climate. It's like we've taken 2 ice cubes and thrown them into a warm room, and now we're standing back and watching and wondering how long it's going to take for them to melt and how quickly that will happen. So when this paper came out, or at one of the earlier papers, we worked with Climate Central to help develop some graphics, and they developed some graphics online that people could interact with to raise sea level by 6 meters and see what would happen. You can see most of South Florida disappears, which makes sense because, in fact, when you go and look at the rocks at those places, they are shallow marine and they are last interglacial in age. We know the oceans were there during that time period. New York City is also shown on the right. You can see what that would do, especially the lower part of Manhattan that goes underwater. So when I talk about these past warm periods, I've had some of my colleagues who are more atmospheric climate scientists say, you know, it's really the paleo people who are the depressing people. And I've been called depressing Dr. Dutton before, right? And, you know, because this is a little bit depressing. The good news is that if this is right, and you know, even if we're off by a few meters, it's still a lot. It's not going to happen overnight. But that begs the big question of, well, how quickly is it going to happen? Which is, it turns out, a much harder question to answer because there's a lot of uncertainty in the dynamics of those polar ice sheets as they retreat away. But it also matters where that meltwater comes from. Is it the Antarctic ice sheet that's contributing? Is it Greenland? Or is it both? Because those ice sheets have what we call fingerprints. And this results largely because of a gravity effect, that the water in the oceans is attracted to all of that mass in the ice sheets. And as that melts, that attraction decreases. So you get a sea level fall, shown in the dark blue, close to the ice sheets, and an amplified signal of sea level rise far away. So somewhat counterintuitively, you would be more affected by sea level rise from the Greenland ice sheet if you are far away from it than if you are close to it. Which means along the east coast of the US, we need to worry more about the West Antarctic ice sheet, for example. So when we look at this example of the last interglacial that I have been working on, we came up with a sea level budget. And this sea level budget implied in the green space that we have about 2 meters of meltwater that was contributed from the Greenland ice sheet. We know that that ice sheet retreated partially during that period, but not completely. But we know that the total amount, based on what we see in these sea level records and what we call the far field, far away from those ice sheets, shows us we had somewhere between 6 to 9 meters. So to get there, in this paper, we concluded there's no way you can do that without tapping into the Antarctic ice sheet. It turns out there's more uncertainty to it than that, because if you look at the error bars, they are very big. But nonetheless, we do need contributions from the polar ice sheets to get anywhere up that high. So what is the tipping point for the Antarctic ice sheet? There's a lot of talk these days about tipping points, and are we at them, or when are we going to get to them, and how does that work? For me, the real problem with the whole conversation about tipping points is you don't really know where they are until you're past them. And you say, oh yeah, there it was. right? That's when we went from millimeters of sea level rise a year to centimeters of sea level rise. And that's when we will have 100% certainty on where that tipping point is. So in terms of the West Antarctic ice sheet, as the waters warm in the Southern Ocean, it kind of bathes the underbelly of that ice sheet. And because the land is depressed under the ice, as it starts to retreat, it goes down that deepening slope, and it's basically no way to stop it once it starts doing that, which is a problem, of course. And this is the front of the Thwaites Glacier. This is thought to be one of the most vulnerable sectors of the West Antarctic ice sheet. Now, there are scientists here at this meeting who have published and said that they think we are already past this tipping point. Regardless of whether we are near it or at it or past it, that this knowing where the tipping point is not something that we will know for a long time. Nonetheless, the actions that we take today, the less that we warm things up, the less bad we can make things in the future. Even if we do pass this tipping point, there are important choices that we can make today that will affect that future. So when we think about the deep past and what the implications are for policy, one of those is the point that I just made, is that our actions today, the policies that we put in place, will affect sea level rise long into the future, right? They will affect things over centuries and millennia. So this is really just the first step in a long journey. The sea level rise that we see today and the projections that you look at, they're often projections to the year 2100. Well, sea level rise is not going to stop in the year 2100. It's going to continue beyond that, which is why I think this framework of deep time is very important for us to carry with us when we think about the choices that we're making today. The other question that we're trying to answer is, what is the nature of this rise? Is it going to be smooth and gradual, or are we going to have sudden collapse of sectors of the ice sheet? So is it going to be more like going up a staircase? Because that's going to make a big difference in terms of coastal planning. And that is one of the things that we are trying to focus on now, at least in my research group. So this, I put in this tweet. I know it's hard to see on this screen because it's very small, but this was something that someone put out that said, the next president of the US gets to set the agenda for the next few tens of thousands of years, right? Which is true. So it really does make a difference. Just a few years, any few years now, or a year wasted, makes a difference in the pathway that we will be on for the future in terms of the bottom panel, which shows different pathways of carbon dioxide, or the top panel that shows different pathways of sea level change. There's one thing that is certain, though, and most people focus on the uncertainty of, well, if you don't know how fast, or if you can't tell me exactly where sea level is going to be in the year 2030, then I'm not going to do anything about it, right? But I like to flip that around and think, well, we are certain that it is rising and that it is accelerating. So we know we need to prepare for it, even if I can't tell you which day that's going to happen on. Because ultimately, as Jeff Goodell put it very succinctly, the water will come. Even if we raise roads or rebuild seawalls, when is anything high enough? It is going to continue to rise. So instead of fortifying our coastlines, we need to think about a new model, a new relationship to the coastline where it's constantly retreating. Again, it's not going to stop in the year 2100. It's going to continue to advance. And we are not going to be able to completely stop that by fortifying our coastlines. Jeff Goodell also wrote, in addition to this book, this article, which part of it appears in the book, called Goodbye Miami. And I've done a lot of outreach work down in Miami. And it turns out that this made him, well, to put it mildly, wildly unpopular amongst certain people in Miami. This article was also, I think, very wildly realistic. It talks about a fictitious Hurricane Milo that hits in the year 2030. And as the waters recede from the storm surge, it covers the lobby of the Fontainebleau with a foot of sand in its absence. And a manatee floats in the pool where Elvis once swam. And it goes on from there. And you can tell just from those first few lines, the power of the storytelling and the reality, it is very realistic picture that he paints of this, is really striking. And it really hit a nerve with a lot of people in Miami. But one thing that it really did do is it started conversation and people thinking about this and thinking about, well, if this is going to happen, how do we want this to play out? And maybe we need to make a more proactive approach in doing so. Which speaks to the power of not just showing graphs, but of also telling stories as we communicate our science to the public. So let's move to part 2, which is talking about recent past in sea level, more on human timescales. This image comes from a piece that ran in the New York Times after a paper that we published where we were looking at tide gauge records along the east coast of the US. And this is a project that I really stumbled into, basically by accident. I had some colleagues at the University of Florida at the time who were working out on the east coast of Florida, looking at geochemistry and pore waters of the sediments. And they wanted to know if sea level rise might be influencing it as salt water was intruding into the sediments. So they pulled up the tide gauge records and said, you know, this looks really strange, and it shows this very rapid acceleration. And they showed it to me. Andrea's the sea level person, go talk to her. And I looked at it, and I said, this can't be right. Sea level has changed by an order of magnitude at this tide gauge. You must have done something wrong. Let me go to the NOAA website. I will get the data for you, and I will solve your problem. I went to the NOAA website. I pulled up the tide gauge data. It was right. Then we looked at the tide gauge data all up and down the US East Coast. Everywhere from the Keys to Cape Hatteras showed the same signal. We had a very rapid acceleration between 2011 and 2015, where sea level rise increased by almost an order of magnitude compared to the longer-term trend. And it was a regional signal. So to put it in terms of inches, which I often do when I communicate to US audiences, we saw 5 inches of sea level rise in 5 years. So if you look at 3 millimeters, which I mentioned before, if you extrapolate that over a whole century, you would get 12 inches, 1 foot of sea level rise. We got 5 inches in 5 years, and there is no coastal community that is planning for 5 inches in 5 years when they hear 3 millimeters a year. What does this come from? It's a natural variability in the system. We looked at tide gauge records going back as far as we could, about a century for some places, and looked to see if we'd seen rates like this before. And we had. Sometimes they occurred in the southeast, sometimes in the northeast. And these sometimes are referred to as hotspots of sea level rise. You get these localized areas, you get these rapid accelerations. And it turned out this is a natural variability in the system. It's probably due to, we concluded, the superposition of the North Atlantic Oscillation that focuses where it happens, and the El Nino, which causes that sea level to rise, the cumulative effects of El Nino. So as these natural variations happen in our atmosphere-ocean system, you're going to get natural variations in sea level along the way. But it was an important message because when I went to talk to the local council people about this, they saw this information, and when I said the number 5 inches, their eyes nearly popped out of their head, right? So this is something that they need to think about in terms of moving into the future. When they look at sea level rise projections, they need to know that there will be variability around those curves as we move into the future. So these brief accelerations are a threat, in fact, to the entire eastern seaboard. They produce these very high rates over the course of a few years or so, and then they decelerate. And that has important implications for coastal planning as we move into the future. But it's not really well understood exactly what is controlling the exact timing of them or being able to predict where they will happen, which is something that we're working on doing. Very briefly, I want to show you some results from some recent work that's in review right now. These are the most complicated graphs I'll show today. But the one in the upper right is looking at the signal from 3 different regions. The eastern US and the pink curve at the top. The red in the middle is from the southeast US, just that southeast section I mentioned before. And then the blue is the Gulf of Mexico. And this is showing the results from an EOF analysis, which is basically shows about almost 80% of the variation, the spatial and temporal variation that is in the sea level signal in these different regions. And you can see that the different regions are basically tracking together. When you get pulses of sea level rise in one place, you get a pulse of sea level rise in the other. We would love to be able to predict when these pulses of sea level rise happen. And so we looked at a number of different things that we thought might be controlling them. And we came up with a few different indices, one of which did not perform very well, but one of which did, the black line that extends to the right, perform very well. So that black line matches what was happening in the Gulf of Mexico, which is in blue on the bottom, fairly well, and might be able to help us predict the timing of when these pulses of sea level rise will come, which of course for the coastal planners is information that they would really like to have. And this speaks to something else that we're going to see in the future as our science moves forward, is that we are perturbing our system so quickly that we actually might live to see some of the results of our predictions that we are making as scientists, which is something that we haven't necessarily had before. And it's, in a way, somewhat perverse way of looking at what's happening in terms of all this very rapid change. We're going to learn a lot of science along the way about how the Earth system works. But it is not something that I take much joy in when you make these predictions and you actually see them come true, or you see them come true even faster than you thought that they would. Okay, so my expectation, though, as we move forward, is that research is going to increasingly focus on solution-oriented applications. So while my main focus of the research is deep time, I'm really interested in this recent stuff because it has immediate applications for the communities that I am talking to and interacting to on a daily basis. And one of the ways we can do that is by focusing on aspects that will contribute to their decision-making framework of how they adapt to these changes as we move in the future. And additionally, I expect that there's going to be a lot of synergy between human behavioral science and the projections and the processes that we understand about climate and climate-related impacts. Because as I mentioned before, there's a lot that we understand about it, but clearly the message is not getting across to the point where people are ready to take action on it in most cases. And there's a lot of space in there that we need to connect and to close down. So those two things are things that are directions that I think will move into the future. So part 3, the future, is intentionally blank. Because I think this is a good time to remind you that the future is not just a place that we get to go to when we wake up tomorrow or in a week or in a month. It's a place that we get to create together. The pathway that we're on is not decided, even though sometimes we look at those projections and we say, oh, we're on that worst pathway, we're doomed, that's where we're headed. There are choices that we can make that can put us on a different pathway. And I think when you work on this from a day-to-day basis, there are a lot of people in this room who work on climate change and who try to communicate it and get depressed about it. And I do that too. But it's important to wake up and remember that we can make a difference and we can make choices that will set us on a different pathway. And I think that is empowering, and it's something that can move all of us forward as a community and the people that we talk to about this as well. So this is the main tool that gets used in communicating sea level science to the public. Sea level rise projections. This one is taken from the National Climate Assessment here in the US, so it's shown on a scale of feet. I apologize. Terrible units to think about. But when you look at this, and when I show this to a public audience, they think, they've got no idea what's going to happen, right? Look at all the different options. I didn't have to be a scientist to draw that diagram. I could have done that, right? Put a nice rainbow color. You guys have no idea what's going to happen, right? Why should I do anything about this? And again, it's about flipping the coin. Instead of focusing on the uncertainty, to focus on the certainty part of it. We know it's rising. We know it's accelerating. I would argue for getting rid of the bottom curve on all of these plots, which is a linear extrapolation, because we know that's not going to happen, and we shouldn't put that there. On the other hand, we use these all the time to convey what we understand about sea level science, but I can guarantee to you that sea level rise will not look like this, which is a big statement coming from a scientist. We never say the words guarantee, right? This is a very useful tool, and these are useful projections, but sea level rise is not going to look like any of these curves. Why not? This is not how sea level behaves. It behaves like this. This is real tide gauge data from Virginia Key. You all know that the tides go up and down every day. There are also annual variability that you can see in each of these peaks in the dark blue. Along Virginia Key, we get the king tide season, or the highest tides of the year happen in the fall, which is when those peaks are. And I know you can't read the notations on here, but some of these peaks over here are from Hurricane Irene on the left, Hurricane Rita, Hurricane Wilma, Hurricane Sandy, which did not make landfall in Florida, but the storm surge, or the swell from offshore was enough. It took out part of A1A along Fort Lauderdale. And then boom, to the right, those last 3 peaks are just king tides. King tides at the level of what used to be only hurricane level storm surge, because sea level has been creeping up in the background. This is what the future of sea level rise will look like. It will be an increasing frequency of high sea level events. It's not going to be the year 2060 when we hit 2 feet. We're going to hit 2 feet before then, but just an increasing frequency until it's permanently at 2 feet. And that is a much better framework to think about that future. So instead of using those curves to say, well, when are we going to be at 2 feet? We should think about it in terms of the frequency of coastal flooding. And this is a framework that is starting to be used. This report came out of NOAA talking about the frequency of coastal flooding and high tides, which doubled in the US in just the last 30 years. Some of the dark red points that are shown on this map are places where there is more than a 200% increase in the frequency of coastal flooding only compared to the year 2000, right? Which is astounding. And that was an analysis done in 2017. The last couple of years, maybe we're up to 300%. I'm not sure. But the point is that sea level rise is going to happen sooner than you think, which is always my answer when someone comes up to me after a talk. Well, what do we expect here? How high is it going to get? And it's going to happen sooner than you think. And that is already playing out. This is a picture Richard Alley in his talk this morning that kicked off today's events, put up another picture from this community. They have been underwater for more than 80 days now. This is in the Florida Keys, and this neighborhood has no wake signs in their roads. They want you to drive slow in the salt water because those roads have been underwater for more than 3 months. And it hit me when I was thinking about this. It's not just about the frequency of coastal flooding. It's about the number of consecutive days of flooding and how that might cripple you in terms of your ability to go to work or to get food or to do what it is that you need to do. So it's not just about, is it going to happen 5 days in a year, or is it going to happen Monday through Friday for an entire week is a different story, which is another metric to think about as we move forward into the future. Also in the news recently is what's happening at Sugarloaf Key. Sugarloaf Key is much farther south, closer to Key West. There was a report released, it was about a week before last week, so maybe 2 weeks ago, that focused on a 3-mile stretch of road on Sugarloaf Key. They're talking about raising the roads as they have done in Miami Beach. So they looked at this study and said, well, using our sea level projections by the year 2025 would require raising it by 1.3 feet and would cost $75 million to protect these 12 homes along this 3-mile stretch. 2045, to raise it to about 2.2 feet, $128 million. By the year 2060, the cost goes out to $181 million. The thing that I've never really understood about raising roads is that when you raise the road, that water has to go somewhere. And so it actually makes the flooding worse on the property adjacent to that road. So for those residents that they're trying to help, they will actually be making the flooding on their properties worse if they were to do it. However, when the local politicians saw these numbers and realized how much it was going to cost, their response was this, and I quote, "Officials in the Florida Keys announced what many coastal governments nationwide have long feared, but few have been willing to admit. As seas rise and flooding gets worse, not everyone can be saved. It's too expensive for them. They can't do it." And this is something that was inevitable. And while many people heralded this as a real step forward, which it is, simultaneously, I think I was banging my head against a wall, thinking, I've been telling them for so long that this is coming, and we need to plan for this. And we need to think about how we want this retreat to play out, because that retreat is inevitable. But I'll tell you what, you go down there and you use the R word, people do not want to talk to you, right? I was told once when I talked to a group of coastal developers in Miami, and I was talking to one of them afterwards, and he said, oh, I talked to some friends and they know you're in town this week. They know I'm in town. And that's how scared they are of hearing the truth about what is coming. Hearing the truth can be scary, right? But this response, the knee-jerk response of communities to build hard infrastructure, raise the roads, put in a seawall, is not a sustainable solution. If you put in a hard seawall, to me, it's kind of a scary thing. Even in a place where seawall might work and you don't have porous bedrock like you do in South Florida, At some point, that seawall will get breached or it will fail. And when that happens, you trap water on the other side into a community that has become increasingly complacent because they thought they were protected by the seawall. They have become, in a way, more vulnerable because you put the seawall there, and they are no longer prepared to deal with the flooding that will come at some point. Also, it gets back to this point of social inequity that I raised before. Only the communities that can afford to build the seawalls will put them in, which makes it even worse for the people who can't afford it. So the knee-jerk reaction to build this hard infrastructure is not going to solve our problem as we move forward. Several years ago, I was quoted in the New York Times with this quote. I said, "It's as if the country was being attacked along every border simultaneously. It's a slow, gradual attack, but it threatens the safety and the security of the United States." That quote spoke to a lot of people because it gave them this idea that we're being attacked and we need to protect it. And I realize in hindsight, maybe that's not the best thing, because digging your heels down and saying, this is our border and we will reinforce it, we will not retreat, is not the right approach. Because a lot of people think the word retreat is synonymous with the word defeat. To me, winning against this is retreating, because you would be taking yourself out of that most vulnerable zone into a place that is better. But it's not like we can just pick up all of our cities and communities and move inland. It's obviously more complicated than that. So what does resiliency in coastal communities look like? This was held up as an example after Hurricane Michael tore through the panhandle of Florida only last year. It feels like a long time ago, but it was October last year when this happened. This picture was published in the New York Times of a wealthy person who built this very large house and built it not to code, but above code, in a way that it would withstand winds, hurricane-force winds, and storm surges. And you know what? His house survived. Is this resiliency, though? Because, yes, his house survived, but he's got no neighbors, no electricity, and probably not access to fresh water. So resiliency is not something that can be achieved on an individual level. It has to be a community-wide approach, which is why when people talk about the Green New Deal in terms of solving problems, when we start to think about social inequities and people that are left behind, we have to remember as we move forward that this is not the solution to resiliency and adaptation. Planning for sea level rise is going to be essential. If we do choose to build infrastructure, we need to know what's coming. This report from earlier this year was, in a word, a little bit depressing. After a $14 billion upgrade, the Army Corps of Engineers had just finished a levee in New Orleans, but it was only 4 years away from becoming inadequate due to rising sea levels. A $14 billion investment, yet not adequately planning for sea level rise in the future, which is why the policies we make are so important as we move into the future to adapt this. So as I wrap up here, I want to think about some of the things I've been talking about. As we are scientists and we talk to people about what is going to happen, that there's understandably a very strong emotional response to the reality that is our future. So it's unfair for us to go in and say, well, this is what I understand, this is what's going to happen to sea level rise, and this is what you need to do, and just expect everyone to get on board to it. When I started this talk, I talked about communicating to people and how it's a two-way street. And by doing that, we're not allowing people to go through this whole range of emotions that they need to go through to get to the side of actions and acting on this information. So I've put up this 5 stages of grief because I feel like in a way what we need to do is send a team of people into all these communities to talk to them about the responses, like how do you feel about this information that you've just had? And let them go through all these different stages that many of us have already gone through. We're angry at the position we're at. We bargain, we get depressed. And sometimes when you come out the other end of acceptance, you don't always stay there. Sometimes I slide back down that hill and I get depressed too. And what picks me back up again is knowing that there are solutions and that we can work together to build a better future. And that's in part what keeps me on the upside of this curve. But I think remembering to be humans and have that conversation with people is really an integral part of communicating the science as we move forward. So in the future, we live in a very rapidly evolving landscape. That landscape is changing from sea level rise as well as many other things. And yes, we're going to learn a lot about how the Earth system responds to those changes in the future. But I feel that we also have to acknowledge the emotional landscape that is connected with this and all these changes that are going on. Listening is an extremely important part of communicating the science that we do. So I would encourage you, as you leave here, to think about ways in which you can talk to other people, people you don't normally talk to, and have these conversations with other people. I have entertained the idea, I don't know if I'll actually do it. I'm a soccer mom on the weekends. I put on my cape and I convert into someone else. And I spend a lot of time doing this. And I thought, maybe one day I'll set up a little booth at the soccer field, ask a scientist, just totally innocuous. And people will come up and strike up a conversation with me, and we'll get to talking, and eventually, well, I can't answer all your questions on science, but I do know a lot about some certain things, and have conversations with people that I don't normally talk to about this. And maybe they will then go have conversations with other people. And so I think we all need to maybe think more creatively about how we can communicate, because all of us can make a difference on this pathway into the future. And one of those differences is finding a way to increase the diversity and inclusion of underrepresented and marginalized voices within the sciences and within this conversation, and connecting to communities that maybe you do not connect with on a daily basis. I would argue that science and scientists must be a part of policy development as we move into the future. I think this is obvious to probably a lot of people, but on the other hand, you also often hear that science should not be politicized. I actually push back very hard on that statement. I think science should not be partisanized, but that it is extremely important in discussions of policy. So I encourage you to go forth and to engage, because personally, I'm not particularly happy with the 1 degree world, much less what might become under 1.5 degrees or 2 degrees. Thank you for coming today and for your time.
Ladies and gentlemen, please welcome Catalina Oida.
So thank you, Andrea, for that. We don't have time for questions on the stage, but Andrea has volunteered. Maybe she doesn't know this yet, but she has volunteered to stand to the side. So if you do have any questions or concerns or want to follow on the discussion, please go ahead and do so actually behind the blue screen over here. So thank you very much.
Thanks.
And to close off today, I want to invite Catalina Oida, who is one of our fearless leaders who actually put together all of the programming that you saw on the stage here for the Earth's Interior Day, and that was finally culminated with Andrea's wonderful talk. So can I invite Catalina to come up and give us some closing remarks from the day?
I'll try to be brief because I know we're all probably ready to go to dinner. But I do want to thank the speakers of today for being so inspiring and so thought-provoking. I want to thank the audience for participating and for attending and for being here, and as well as the planners, because it takes a village, as they say, and really there are a lot of ideas and efforts and support. So I want to thank the AGU staff, notably Victoria Forlini, the fellow AGU council members who have put most of these sessions together with us. And as we reflect back on the day, I just want to share a couple of quotes, really paraphrasing some of today's speakers. So starting this morning, we were reminded that knowledge is not optional, it is essential. How we respond to the day defines who we are tomorrow. how we go from impact with little I, so impact factors, to big impact to society and the environment. That water is now limited to scientists. It's a shared odyssey and a shared resource. And to approach climate change and its impacts and the inequity that it causes with humility, by listening, by conveying culturally appropriate messages. And as Andrew just stated recently, resiliency cannot be achieved at the individual level. It has to be done collectively. So there are many challenges ahead, as today's speakers have highlighted for us. But there's so many of us here today and this week, and even remotely, a community of dedicated, brilliant scientists leading the way. And in the words of First Lady Michelle Obama, you will not always be able to solve all of the world's problems at once, but don't ever underestimate the importance you can have, because history has shown us that courage can be contagious and hope can take a life of its own. We stand at the intersection of history as we look forward towards the next 100 years for Earth and space science, for the planet and society as a whole. We have to be the stewards of knowledge, of the science of the past 100 years, of inclusivity in science, and the stewards for sustainability of our planet and our future. And finally, to paraphrase Mae Jemison, who spoke yesterday at lunch, ideas are like potential energy. If we need to transform that energy to do work, to put them into action. So let's move forward together and inspire, innovate, include, and put ideas into action. Thank you, and have a great rest of the week.